Okay, the same physical properties are found in the non-metals also. So what are those non-metals? For example, diamond and allotrope of carbon. So what is the allotrope? Allotropes means physical properties are different but the chemical properties are same. Okay, so for example, diamond, allotrope and carbon. These three, diamond, carbon and graphite, these three are the allotropes. Okay, graphite. Why we say these three are the allotropes? Because these three has the same same chemical properties. What is the same chemical property these three has? The chemical property of the color of black. These three are the color in black, but their physical properties, maybe their shape and their uses are different. Physical properties by appearance, these three are different physically, but chemical properties are same. So if the physical properties are different, chemical properties are same, means it is called as a allotropes. Please near the allotropes underline that allotropes and write the definition. Allotropes means physical properties are different but chemical properties are same. Okay, so here we are going to see some properties that are same in the metals and non-metals. For example, diamond, carbon are the allotropes. Has shine and is also thermal conductor. Thermal means what? Heat. So they can transfer the heat. Okay. So another allotrope of carbon, graphite, is a grey in color and conductor of electricity. So diamond, an allotrope of carbon, diamond can be a thermal conductor which conduct the heat. Conduct means what? Transferring heat. Okay. When we keep the dish on the gas, that dish will be conducting the electricity, aluminium dish. That means heat, when it heats up bottom, the heat slowly will be spreading to the whole dish. This is the conduction of the heat. Another allotrope of carbon is the graphite. Graphite can be used as a conductors of electricity. Actually, metals only conduct the electricity, na? But here we see now diamond, allotrope of carbon means like carbon. Another one is there diamond. It can conduct thermal conductor. An allotrope of carbon, graphite. Graphite can be used as a conductor of electricity. Iodine is a non-metal but has shiny crystals. Iodine means salt, na? Salt is a non-metal, but when we see the salt, it has the shiny crystals. Therefore, it is not right to classify an element as metal or non-metal based on only physical property. So, seeing the physical properties, we cannot differentiate the metals and non-metals, because some properties of the metals and non-metals are same. Which properties? The physical properties of the metals and non-metals are same. Okay. So these are the characteristics of the physical properties of the metals.
Physical properties of metals. Metals possess certain characteristic physical properties which distinguish them from non-metals. Physical state. Metals are generally solids at room temperature. Mercury is a liquid metal. Unlike other metals, sodium and potassium are quite soft and can be cut with a knife. Metallic luster. Almost all metals possess a characteristic luster. They can be polished to increase their shine. Here are some examples of highly polished metals. Malleability. Metals are malleable. This means that they can be converted into sheets or foils by hammering. Gold is the most malleable metal. You must have seen the thin foils of silver which are used for decorating sweets. Aluminium foil is used for wrapping eatables like chocolates, etc. However, arsenic, antimony and bismuth are brittle and exceptions. They get powdered on hammering. Ductility. Most metals are ductile. A substance is said to be ductile if it can be drawn into wires by stretching. Gold is a highly ductile metal. 1 gram of gold can be drawn into a thin wire 3,240 meters long. Electrical conductivity. Metals are good conductors of electricity. Silver and copper are very good conductors. They are used for making conducting wires. Lead and mercury are exceptions. They have low electrical conductivity. Generally, the electrical conductivity of metals decreases with increase in temperature. Thermal conductivity. Almost all the metals are good conductors of heat. When a piece of metal is heated at one end, the heat travels towards the other end, and the whole piece becomes hot. It is due to this reason that metals are used to make cooking utensils. Density. Density is the degree of compactness of a substance. It is the mass per unit volume of a substance. The densities of metals vary from 0.53 grams per cubic centimeter for lithium to 22.5 grams per cubic centimeter for osmium. The metals whose density is less than 5 grams per cubic centimeter are called light metals. Some examples of light metals are lithium, sodium, potassium, magnesium, aluminium, etc. Other metals like iron, copper, silver, gold, etc., whose density is more than 5 grams per cubic centimeter, are known as heavy metals. Metals are sonorous. Sonorous refers to a loud, full or deep resonant sound often produced by metals when struck. Many metals, when struck, produce a specific ringing sound. Due to this, they are used to make bells and gongs.
Malleability. Place any one metal on a block of iron and strike it 4 or 5 times with a hammer. Observe the changes in the shape of the metal. You will find that some metals can be beaten into thin sheets. This property is called malleability. Gold and silver are the most malleable metals. Ductility. The ability of metals like iron, copper and aluminium to be drawn into thin wires is called ductility. Gold is the most ductile metal. For 1 gram of gold, we can draw a wire of 2 kilometer length. Can you name some metals that are used for making cooking vessels? Let us do the experimental activity to find out the answer.